Perspective Class 6 Video 2. In this video we're going to talk about parameterization of lines in three-dimensional space. In the previous video we spoke about parameterization of lines in two-dimensional space. Well, the biggest benefit of parametric equations of lines is that they easily generalize to higher dimensions. And I honestly do mean it's an easy generalization. I think if you can do parametric equations in 2 dimensions, then you can do them in any number of dimensions. It's essentially the exact same process, no matter what dimension you're looking at. And this makes parametric equations of lines a really useful tool in when you're studying this sort of geometry. We never mentioned it when we were talking about lines in 3 dimensions in a previous class, but it is actually non-trivial to find an equation of a line in 3 dimensions. Like in 2 dimensions, you can easily find some sort of y equals mx plus b, or if that doesn't work, you can find like x equals a in 2 dimensions. Right? In 2 dimensions, one of these will work. In 3 dimensions, you can't just have one equation which describes a line. So if you have something, y equals 2x plus 3z or something, this is not a line. It's not as easy as this. As soon as you have more dimensions, you can't use this same sort of technique. And by far the easiest way of describing a line in 3 dimensions is using parametric equations. I mean, you can do parametric in 2 as well. And we spoke about that last time. But in 2 dimensions, you sort of have a choice between parametric or this type, which you'd probably call Cartesian equations. But in 3 dimensions, no single Cartesian equation can describe a line. So instead, you have to use parametric equations. So let's just recap the definition. It's directly analogous to the 2-dimensional definition. This definition says that an expression of the form ABC plus t times PQR, where t is a real number, describes a line in 3-dimensional space. Okay, there's no reason why I chose P, Q, and R. I was just running out of letters, so I thought it would be nice to change things up. Okay, this is a parametric equation in 3-dimensional space. The general form of a 3D parametric equation is this: a vector plus t times a vector, where t is a real number. The only difference now is that our vectors are 3-dimensional vectors. And again, we often abuse notation and we often just write u plus tv. So maybe I'll give you another interpretation of parametric equations before we move on to an example. So let's say we're dealing with a parametric equation and it's u plus tv, like that. How can you think about this? Well, if I try and draw some coordinate axes, now I'm in 3 dimensions, so I'm going to draw a 3-dimensional x, y, z. Okay, so how do you interpret this? Well, one way is, you can think this is the vector u, and the idea is, think about the line being traced out by like an airplane in the sky. And the airplane at time t equals 0 was spotted at the vector u. And it was spotted traveling in the direction v. Okay? And as time goes on, so t sort of, you can think about t as time. As time goes on, the airplane is going to travel in the direction v. So after like 1 unit of time, the airplane is now going to be here. After 2 units of time, I didn't draw a very good arrow, so I'll draw it again. Like, this is time t equals 1, this is maybe time t equals 2, and you can even go backwards in time, right? So at time t equals minus 1, where was the airplane? Well, the airplane was there. Okay, so you can interpret a parametric equation as sort of like telling you, where did you spot the airplane? What direction was it traveling? And then t is the time parameter. It tells you, if you plug in a certain time, where is the airplane going to be? That's how you can think about parametric equations. So let's do an example. This example just says calculate the parametric equation through the line, calculate the parametric equation of the line through these points. So the point 132 and the point 406. So we know the answer is going to be something of the form u plus t v. I just need to work out u and v. I can let u be either one of these. I'll let u be the first one for no particular reason at all. And then to work out v, you sort of solve this equation. U plus v equals this. So this means that v equals 406 minus u, which is 406 minus 132, which is 3 minus 3, 4. So the answer is going to be 132 plus t lots of 3 minus 3, 4. And that's it. That's the parametric. That's a parametric equation of the line through these points. Like I said in previous videos, there's not just one correct answer. There's infinitely many correct answers. Okay. For example, I could have chosen u to be 406 instead. Okay. There's infinitely many correct answers, but this is just this is one correct answer. Okay. So that's the end of this example, and that's the end of this video.